Hello and welcome to another Chapter 8 practice problem. This question is similar to question 31 in Chapter 8, finding the confidence interval for proportions. The problem we will be working with today is a simple random sample of 600 individuals provides 120 yes responses. What we need to find is the point estimate of the proportion of the population that would provide yes responses to 2 decimal places, the estimate of the standard error of the proportion to 4 decimal places, and to compute the 90% confidence interval for the population proportion to 4 decimal places. Part A is asking us what the point estimate of the proportion of the population that would provide yes responses is to 2 decimal places. The point estimate of the proportion of the population is the p-bar of the sample. It is found by taking the total of responses that we are interested in and dividing it by the total responses sampled. So in our case, we have the 120 yes responses divided by our 600 total responses, and 120 divided by 600 gives us a p-bar of 0.20. Part B is asking us to find the estimate of the standard error of the proportion to 4 decimal places. I have the formula we will be using through our problems up here in the corner. The standard error formula that we will be using is part of the confidence interval for P formula. It is this part outlined right here of the square root of P bar times 1 minus P bar divided by n, and we multiply that by the finite correction factor if it's appropriate, which is the square root of capital N, our population size, minus little n, our sample size, divided by our population size minus 1. So before we go any further, are we allowed to use the finite correction factor in our question here? Well, no, we're not allowed to use the finite correction factor because we were not given a population size. So with our terms that we're going to be using outlined here in the bottom, we have p bar equal to 0.20 and our sample size being equal to 600. We can plug that into our formula, which gives us 0.20 times 1 minus 0.20 divided by 600, and we take the square root of all of that, which gives us a standard error of 0.0163. Part C is asking us to find the confidence interval for the population proportion. We will be using the formula for the confidence interval for P, which is P bar plus or minus the z-score of alpha divided by 2, times the square root of P bar times 1 minus P bar divided by n, times our finite correction factor of the square root of capital N, our population size, minus little n, our sample size, divided by our population size minus 1. I defined our terms down here as p bar equal to 0.20, n is equal to 600, and our alpha, which we need to find the z-score of alpha divided by 2, is 0.1. So before we go any further, I believe that we should discuss on how to find this z-score of alpha divided by 2. So in order to find the z-score of alpha divided by 2, we first need to prove that we are allowed to use a z-score. The only proof for proportion data is that n times p is greater than or equal to 5, and that n times 1 minus p is greater than or equal to 5 as well. So in this case, n times p is equal to 120, and n times 1 minus p is equal to 480, so we are allowed to use a z-score. The way that you find the z-score of alpha divided by 2 is by taking 1 minus your confidence coefficient and dividing that number by 2. So for our problem, we would take 1 minus 0.9, which gives us 0.1. We then divide that number by 2, which gives us 0.05. Lastly, we need to find the corresponding z-score for that area to the left on our z-table, which is shown in the picture right here, which gives us a z-score of negative 1.645. It's important to note, because in this case, our alpha divided by 2 is equal to 0.05, where it falls between 2 z-scores, we add those 2 z-scores together, in this case negative 1.64 and negative 1.65, and divide that by 2, which is where we get our negative 1.645 as our z-score. We add the two z-scores together only if the point we are looking for is equidistant or of equal distance between these two z-scores. Otherwise, we would use the z-score that has the area to the left closest to the area that we are looking for. Now that we found the z-score of alpha divided by 2, we can plug all of our terms into the equation above. Our formula that we're going to be using is p bar plus or minus the z-score of alpha divided by 2 times the square root of p bar times 1 minus p bar divided by n times the finite correction factor if it's appropriate, which is the square root of capital N, our population size, minus little n, which is our sample size, divided by capital N minus 1. So for our calculation, remember that we cannot use the finite correction factor because we are not given the population size that our sample is taken from. So with our terms over here on the bottom, we have p bar equal to 0.20, our little n, or our sample size, is 600, and the z-score of alpha divided by 2 that we found was negative 1.645. So plugging it all into our equation, we have 0.20 plus or minus negative 1.645 times the square root of 0.2 times 1 minus 0.2 divided by 600, which gives us a 90% confidence interval for p equal to 0.1731, which is less than or equal to p, which is less than or equal to 0.2269. I hope this video was helpful in explaining this concept to you, and I will see you in the next video.